I want to take a look at a couple problems out of section 2.4. It's dealing with epsilons and deltas and the formal definition of limit. The problems at the beginning of this section are sort of getting you ready for actual proofs that come later on. That is, here problem number 4. You're dealing with the function x squared, and they're apparently looking at the limit as x goes to 1. Well, as x goes to 1, x squared is also going to 1. So here's the f of x minus L right here, being less than something. So it looks like they're choosing epsilon here to be a half. And the question is, what delta do we need so that the x's that are close enough, that is no more than delta away from 1, will give me function values that are no more than a half away from L equals 1 here. This one's a little confusing in that the x is going to 1, and I think that the limit is equal to 1, right? So that those two numbers are the same. But anyway, here's what we have to do. We've got to find, they want, we think the limit is 1, and we're saying take epsilon to be a half. So my range here is from 1 minus a half to 1 plus a half. So I've got 0.5 to 1.5, and what I need to do is I need to find the x values that give me those outputs. Okay, so I'm going to take x squared and set it equal to 0.5, figure out what x is, and I'm going to take x squared and set it equal to 1.5. So I'm going to do that right over here. So I've got x squared, I need it to equal 0.5. Well, just take the square root of both sides, and I've got x equals, well, either plus or minus, but I know that I'm dealing on the positive side there because I'm getting x close to 1. So let's just look at the square root of 0.5, whichever is the square root of a half. Anyway, it's 1 over the square root of 2. However you want to write that is about 0.707. Likewise, I wanted to know when was x squared equal to 1.5. Right? I'm going to scoot back over here. So I just calculated this point was 0.707. Why did that just do that? This point right here is 0.707, and now I've got the y value of 1.5. I'm going to see what x value that corresponds to. So that's this calculation here, and x is the square root of 1.5, which is the square root of 3 halves, which is equal to something. Actually, I'm going to grab a calculator real quick here. Here's my graphing calculator. Let's go over here and say I want the square root of 3 divided by 2. So the square root of that whole fraction, so the square root of 1.5 is equal to 1.225, let's say. Okay. So coming back over here, that's 1.225. Now, looking at the picture, I have 1 right here. I have 1 right there. I moved over and down to get this at 1.225. I moved over and down to get this at 0.707. Now, so that tells me that the range of x's that are good are from from 0.707 to 1.225. Okay. However, delta, when they talk about that x, the absolute value of x minus 1 is less than delta. This is describing an interval on the x-axis that's centered at 1 and has radius delta. So you go out 1 plus delta to 1 minus delta. And what I want is I want all the x's in this range to give me y values in that range. Okay. These are all the x values that work, but this isn't necessarily centered at 1. That is, the difference here is 0.293-ish, and the distance here is 0.225, right? So this is actually a shorter distance on this side than it is on the other side. Okay. Well, if I want all of these x values, which are centered at 1, to be within this range, then delta had better not be any bigger than the shorter of those two distances. Well, the shorter of those two distances is the 0.225, and so that's what I want delta to be. Delta equals 0.225. So I find the two endpoints, and then I compare them to 1. How far away from 1 is the right endpoint? How far away from 1 is the left endpoint? Delta will be the smaller one of those two. Okay. Notice that with this thing, if this were a straight line, if your function's a straight line, then moving up by epsilon is going to move you over by a little bit, or moving down by epsilon will move you back the other way. And that if this is a straight line, the slope here is the same as the slope there, then this side will be the same as that side. But with a curve, like this one where it's curving, right, that the same amount of epsilon rise or epsilon fall with the function going up faster, you don't have as big a gap here. With the slope being less on this side, you have a bigger gap there. So when I'm looking at this thing here, with it bending this way, the right-hand side is steeper, and so the right-hand side is giving me the shorter gap here, and that's what I'm choosing for delta. On some of the problems, your function might be bending the other way. So you're approaching this value of x, you think the limit is right there, you say L minus epsilon, L plus epsilon, and move over and down, and you say, oh, look at this side is steeper, and so it gives me a smaller gap there. With this side being less steep, it gives me a bigger gap, and so delta is going to be the smaller one. Okay. Again, for the most part, we deal with, at least at this stage of your life, if we're going to do proofs, we're going to stick with linear functions. But if it's not linear, then you just have to compare the two sides and figure out which side you want for delta, right? Because you're going to, and you take the smaller one because you're going to make an interval centered at this point with whatever delta is. If you take the bigger one, if you say center here but use that radius, well, then you're going to get x values out here which are no good, right? So take the smaller one. So that's that was number 4. I also want to look at number 7. Okay, if it'll let me look at number 7, which here we go. For this limit, find the value of delta that corresponds to epsilon equals 0.2 or 0.1. Let's start with 0.2. I think I'm only going to do one of them and let you do the other. So the thing is, here's my function, x cubed minus 3x plus 4, and we think the limit is 6. We're saying the limit as x goes to 2 of x cubed, is it minus 3x? Minus 3x plus 4. We think it's equal to 6. Okay, let me just double check here. That's 8 minus 6 plus 4. 8 minus 6 plus 4 is 6, sure. Okay, how do I do that? Well, for epsilon equals 0.2, not 0.02, I want to find delta. So I've got this function here, this x, whatever this thing looks like. Supposedly I'm plugging a 2 in here and getting 6. So I want to move down to 5.8 and move up to 6.2 and then see what x values those correspond to. Okay, so I want to know, when is x cubed minus 3x plus 4 equal to 5.8, and then I'm going to come back and do the 6.2. Okay, well, when is it equal to 5.8? This is a cubic. Generally, I'm not very good at factoring cubic polynomials. So, and in fact, I even noticed that the problem here says that you should be using your calculator. It's they think it's a calculator problem here. So I'm going to use my calculator. Actually, I think I've got this function already in. Already got this function in. I'm going to look at its graph. Actually, no, I want to put in 5.8 here as well. 5.8. So I've moved down 0.2 from 6, and then I can look at the graph of both those things. So I'm interested here in x is close to 2. So I'm going to zoom in on this point right here if I can. So what I'm seeing here, I'm at 5.8, and my y value here is, I want to zoom some more. This has kind of got a funky zoom to it, and I haven't quite figured out how to keep it centered. But this is giving me a little bit better. 5.8, that's crossing at, what's that, 0.95, 96, 97, 98, 99, yeah. So 97, let's zoom in a little bit more. See if that helps me. No. 1.97, there we go. I just got a little bit better accuracy. 1.9698, so 97. What are these? These 0.4? Yeah. So 0.97. I don't know. Maybe 0.975, something like that. I could zoom in and get a little better. If you got your TI, you can probably just say where's the intersection of those two and let your calculator tell you exactly what it is. But what I'm seeing is that x value is about 1.975. So back over to here. X equals 1.975. Okay. Now I want to do the same thing here. X cubed minus 3x plus 4. I want to see when is that equal to 6.2. So back over to here, go to my equations. Let's also look at 6.2 and save that. Go to the graph, zoom out some. Alright, so now I want to look at this point here where it's 6.2, where my red graph is crossing over. Zoom in. This is a really goofy zoom, but there we go. I'm at about 2.2 something here. 2.2, it's 2.02. 2.021, 2.0219, 2.0219 is what I think I have here. Okay, so on the number line, 2 is right here, and my two cutoff values, left and right, 1.975, 2.0219. Which one is closer? Which one is closer? This difference here is 0.025. This is 0.0219. There you go. Delta, looks like an 8. Delta equals 0.0219. If they give you an epsilon, you got to figure out what x values work. So find the left point and the right point by plugging in L plus epsilon and L minus epsilon, solving for x. Once you've got those two, calculate those two lengths. How far away from the point you're interested in? How far away are they? Whichever one is closer, a smaller value, that's what you want to be delta.